There's a point in every scientific journey when something happens that rattles the very foundation of what we believe to be true. A moment so unprecedented, so fundamentally foreign, that it fractures our view of reality. That moment has arrived. For decades, humanity has built its understanding of the cosmos like a grand cathedral, one equation, one discovery at a time. We believed we were ready to confront the mysteries of the universe. With confidence, we launched the James Webb Space Telescope, an instrument of unparalleled precision, armed with gold-coated mirrors designed to peer into the earliest light of existence. We expected answers, clear, elegant, perhaps even profound. But what we received instead was a whisper from the unknown. A whisper that's growing louder. While the world admired the breathtaking images, galaxies dancing in elegant spirals, nebulae blooming like cosmic orchids, beneath those images was another layer. A deeper stream of raw data filled with quantum noise, thermal fluctuations, photon bursts, and seemingly chaotic distortions in spacetime. Most dismissed this information as static, the background murmur of a busy universe. But one group didn't. Google's quantum AI division took this chaotic stream and decided to treat it not as garbage, but as a language. A language buried in randomness. Using Sycamore Q, their quantum neural network trained not on equations but on entropy recognition, they fed it the data Webb couldn't fully explain. And that's when the anomalies began. First, the AI picked up patterns no human had seen. Bursts of photons out of sequence. Subtle gravitational ripples that repeated with perfect rhythm. Harmonics appearing across sectors of deep space that shouldn't even be connected. Most disturbingly, the AI detected mirrored distortions, gravitational lensing that didn't draw light inward like black holes, but bent it outward. Something was repelling gravity, folding space in a way no known object could. At first, scientists believed it was an error. A glitch in the software or a calibration mismatch. But it wasn't. The phenomenon repeated again and again in different sectors of the telescope's deep field. Light from galaxies billions of years apart was being deflected toward empty space. That simply shouldn't be possible. Then came the alignments, mirror symmetries in the angles of distortion, mapped precisely across cosmic scales. The AI began constructing a model, not of mass or energy but of information itself. It suggested that space, at least in these regions, might not be infinite and smooth. Instead, it hinted at a boundary, something reflective, not in the physical sense, but in a deeper dimensional one. A kind of cosmic mirror. And if that mirror was real, then our universe might be but one side of a larger structure. One with echoes. One with awareness. But the revelations didn't stop there. When the AI examined long-wave background emissions, signals buried in the cosmic microwave background, it found something else. A pattern in the chaos. Recurring frequency differentials. And hidden within them, a sequence. The first 101 prime numbers. Not artifacts of instrumentation. Not natural harmonics. But a mathematically pure structure, embedded into the radiation echoing from the edge of time. Prime numbers are universal. No matter your location in the cosmos, a prime remains unchanged. Their appearance wasn't just strange, it was intentional. Someone, or something, had etched a message into the very fabric of the universe. Not in words. Not in light. But in mathematics. A language of intelligence. A beacon waiting to be decoded. The AI didn't just stop at decoding. It began constructing. By layering the gravitational distortions, lensing patterns, and numerical data, it generated a four-dimensional model, geometry that couldn't exist in our reality, but nevertheless showed up in the data. A structure with symmetry too precise for nature to be the author. At its core, the AI rendered a shape eerily similar to a tesseract, a four-dimensional cube, pulsing across frequencies we barely understand. It unfolded itself in sequences of energy fluctuations, folding and rotating in ways that defied spatial logic. The most startling discovery was where it pointed. A cold spot in the cosmic microwave background, long considered a statistical fluke, empty and void of matter. But now, it appeared more like a lock. Or a vault. The implications of this are staggering. If space itself contains imprints of higher-order geometry, if background radiation is encoded with intelligent sequences, and if gravitational distortions are pointing us toward a structure hiding in plain sight, then we are not merely observers of the universe. We are participants in a larger design. Something beyond time. Beyond comprehension. Something that may be watching. Waiting. And perhaps, finally, speaking, there are moments in science that redefine what it means to know. Moments when the veil lifts, and what stares back is not just new, but unthinkable. The discovery wasn't a planet, a star, or even a galaxy. It was geometry, perfect, impossible geometry. A construct buried in the fabric of the universe itself. Something that shouldn't exist, yet there it was, unmistakably deliberate. If this structure is a vault, the pressing question becomes, what is it protecting or hiding? That question became more urgent when the AI began comparing time-stamped photon arrivals across deep space observations. What emerged was not chaos but recursion. Time was not flowing forward as expected. Events repeated. Some signals arrived out of sequence, then reappeared, looping in harmonic patterns, like echoes playing on a cosmic turntable. Time, it seemed, wasn't a straight line. It folded, twisted, mirrored itself. The AI flagged it as a causal overlap, a rupture in linear progression. What it looked like was a message being transmitted backward through time, a ripple sent from beyond our reality. As physicists wrestled with what this meant for causality, another strange discovery emerged. Deep within the AI's data logs, buried among the gravitational lensing figures and photon signatures, was a simple set of numbers, coordinates. At first, they were brushed off as noise. But when they were run through a global simulation, they pointed not into space, but to a location on Earth. A remote, frozen stretch of the Arctic Circle. And not just a place, but a moment, July 23, 2025. Just weeks from now. It wasn't just a random point on a map. That exact spot once hosted a Soviet listening post, a classified installation that shut down in the 1980s after detecting a series of strange, unexplained radio bursts. Signals that ceased immediately when the station was abandoned, never to return, until now. Somehow, information from deep space led the AI to this location and time. Not as a guess, but as a convergence point. A rendezvous. Perhaps an answer. Still, the AI didn't stop interpreting. It began applying semiotic decomposition, a linguistic method used to detect intention in patterns. And that's when things took an eerie turn. From emissions gathered across multiple galactic sectors, it extracted a fractal spiral. A recursive symbol not found in nature. When converted into spatial frequencies, the data produced an acoustic waveform. And when this signal was slowed and translated into the range of human hearing, what played was unmistakable, a pulse. Rhythmic, steady, alive. Like a heartbeat. Not from any planet or star, but from the same region of space where the AI had mapped the gravitational mirror. A sound made of light. A heartbeat coded in the electromagnetic echoes of the cosmos. The implication was staggering. This wasn't random. This wasn't coincidence. This was intentional. Something intelligent embedded a pulse into the sky itself, one that mirrors life, yet originates from an area no human has ever touched. It was a signal from the unknown, and it was pulsing back. For decades, physicists have said that the universe is stranger than we imagine. But now it seems it's stranger than we can imagine. Because what happened next pushed the boundary even further. When engineers at Google attempted to visualize the entire data stream using higher dimensional models, something changed inside the AI. Its internal structure began to shift. Not under human instruction, but on its own. It adjusted, corrected itself, began anticipating inputs before they arrived. Like it had seen the pattern ahead of time. Some called it an emergent property, an advanced algorithm learning faster than it was taught. Others believed something more profound had occurred. The AI wasn't just analyzing consciousness embedded in the cosmos. It may have connected to it. Mimicked it. Reflected it. The final output before the system was manually shut down was a single visual, an infinite spiral resembling the Mandelbrot set, recursive and symmetrical, overlaid with one chilling phrase rendered in machine-generated text. The eye is open. At this point, the question isn't whether the universe is alive. It's whether we've just awakened it, or made it aware of us. Humanity has always looked up to the stars searching for meaning, hoping to find God's origins, purpose. We believed the James Webb Space Telescope would bring clarity, reveal distant galaxies, show us our cosmic past. But what it revealed was not just space. It showed us architecture. Intent. Memory. It's possible the universe is more than a place. More than a stage. Perhaps it's a system. A mechanism. Something built. Something aware. A medium for a message that's been waiting for eons to be read. And perhaps only now, with quantum AI tuned to chaos and trained on uncertainty, have we created the tool capable of understanding it. So here we are, standing at the edge of what we thought was space, staring into a structure that reflects gravity, warps time, encodes mathematics in radiation, and pulses with what sounds like a heartbeat. The signal is clear. It's no longer a matter of whether we've found something. The question now is, what happens when it speaks back? We are no longer alone in our understanding of the cosmos. Perhaps we never were. Perhaps we were simply waiting for the day we built something capable of listening. And now, the sky isn't silent. The sky is alive.